Good morning, everybody. I am Mohammad Naim Hassan Munna, a PhD student, first year PhD student. So today I will discuss based on the topic fate and transport of herbicides and the effect on human health and environment. So I'd like to share why I considered this topic. Basically, I'm going to apply herbicides in some of my experimental plots of my PhD study, and that's why I was interested to know more about this. So, what is herbicide? All of you know, according to the previous lectures of Dr. Basta. However, we can use the herbicide, and it's a chemical that is used to control undesirable herb. So it can be applied in row crop farming, and it can also be applied in the fall season to improve the herbicide. There are so many key processes of herbicide fate and transport. Those might be absorption, desorption, degradation, and movements. So let me show you a short video. I hope it might help to understand about how does herbicide work. Sorry. Is the sound okay?
Proactive herbicides provide extended residual weed control and manage flushing weeds in spring. In the spring, early germinating weeds remove valuable nutrients and moisture from the soil, so you need to get a jump on those weeds, removing them as early as possible before they have a chance to compete with your crops. And the best way to do that is with soil-active weed control, applied either just before freeze-up in fall or soon after spring thaw. Once sprayed, these products sit on top of the soil and move into soil water solution, with moisture from snow melt when applied post-harvest in the fall, or with rainfall when applied in the spring before seeding. The soil-active herbicide moves into soil water solution and forms a tight band near the soil surface. The Volterra and Fierce herbicide particles move around in constant flux between connecting to soil particles and moving in the soil water solution, available for uptake by germinating weeds. These herbicides can remain effective in the soil for up to 8 weeks. As weeds germinate and grow through the soil, they come into contact with the soil water solution and take up the herbicide. Volterra and Fierce help eliminate tough-to-kill weeds before they have a chance to get established and compete with your crops. And they can manage weed flushes for up to 8 weeks, helping your fields stay clean as you get spring seeding done, and helping your crops get off to a strong start early in the season without weed competition. So the best spring start begins with soil-active weed control from Volterra and Fierce.
Okay. Well, so that's how herbicide works in the soil. There might be some details of the absorption process. So absorption is the retention of herbicide compounds onto the soil surface, and it plays a crucial role in determining the herbicide persistence throughout the soil environment, and it will be partitioned between the soil solution and the solid phase of the soil. You can see in the red cycle, I tried to show this on these authors, the absorption or absorption will be increased when that will be like the clay particle, and the less absorption or sorption will be happen for the cations, and it's the sequence from cation to clay. And desorption is the opposition of absorption, so it's like the herbicide will be returned to the soil solution from the solid phase. And in this place you can see the desorption will be higher for the cations. On the other hand, that will be the lowest for the clay particle. So biodegradation is another process of the transport or degradation of herbicides. So it's actually the major route of the herbicide transport, and there will be huge impact of microbial activity and diversity, as well as the water availability in the soil. If the microbial availability is lower, then there might be a chance to form the residue of the herbicide in the soil. For example, if you consider glyphosate, it can be found in the soil up to 200 days if the microbial activity is not that much active. And from this figure you can see atrazine, it's also a herbicide. It can be degraded with the help of different microbes and turns into like DEA, HA, and DIA and DIHA. Volatilization is a non-biological process. So you can see the figure. It can be happen due to the fluctuation of temperature, and it's like the herbicide will be transport from the transformed from the liquid or solid form into the gaseous form in the field. Photodegradation is also a non-biological process, and it's mainly occurred with the help of sunlight. And most importantly, the smog, oxybromide or iron oxide is very helpful, and those are nanocomposites that can help to degrade glyphosate or this kind of herbicides. From this figure you can see if we try to degrade herbicide, for example glyphosate, it can be degraded with the help of the sunlight, the visible light irradiation. So chemical degradation is also another non-biological process, and it's like the chemical reaction in the herbicide. For example, atrazine can be converted into HAT and DEA with the help of hydrolysis and oxidation process respectively, according to Owen et al. 2021. Leaching is also an important transport process for of herbicide, and it is basically the vertical transport process of herbicide from the soil to the by the water. So herbicide may be transported due to the physical movement of soil particles, and it can also be transported with the help of erosion. Most importantly, leaching process depends on the soil properties, for example, water holding capacity, as well as the properties of herbicide. This graph was collected from an article, Lima et al. 2020. So in this study, the author tried to show how the leaching process worked, and they considered phosphate, liming plus phosphate, and one is control. So here phosphate is basically the glyphosate, and we can see based on the depth of soil, for example 0 to 10 and 10 to 20 centimeter depth of soil, the atrazine leaching was higher rather than the other treatments like liming and phosphate and controls. Atrazine is one of the most well-studied pesticide, I should say, or herbicide, because it's extensively used in the USA, most importantly in the Midwest, the Corn Belt zone. So it's also the second most commonly used herbicide in the USA. if you'd like to say the number, so it would be 65 to 85 million pounds sprayed each year, primarily on cornfields in the USA. From this map, you can see, if you consider this region, so it's the Midwest, and all of you may know Midwest is the corn belt, and we produce a million hectares of land for corn cultivation, and we use atrazine or glyphosate as the herbicide. So from this point, the Ohio. So this is the Ohio, right?
Yeah.
Okay. So this region, you can see the west part of Ohio. We are using the highest level of atrazine herbicide, and that is 63.35, more than that, pounds per square mile. So there must be some health effects of atrazine as a herbicide. So exposure through injection of contaminated drinking water, it can be the reason. And there might be some health effect like endocrine disruption that was already mentioned by Dr. Basta in his previous lectures. So it's really dangerous because it will mimic, block, or interfere with our body's hormones. So it's really very dangerous. And it also be responsible to increase the risk of intrauterine growth retardation, reduced semen quality, and spontaneous absorption in human, according to his atrazine in the environment. So when the atrazine or this kind of herbicide will be washed from the soil into the water body, it can be persist for the long time because the half-life of atrazine is 200 days. From this figure, you can see when we will apply herbicide in our field, for example, cornfield, the herbicide can be run off, and that can be eroded, and that can be washed from the soil into this water body, and there are different animals in this water ecosystem, and they also be affected due to the atrazine. And when we will eat fishes or different kind of animals, so we can also be affected by the atrazine. Glyphosate is another herbicide that is also used in the corn cultivation. So the use of glyphosate is increasing worldwide. From this figure A, you can see the graph is it's increasing from 1994 to 2014. The increasing rate is really higher considering the world scenario, and if you consider the United States of America, it's also increasing. And if you consider the number from 1994 to 2014, global inputs of phosphorus, the rate from glyphosate increased from 10.3 gigagram to 151.3 gigagram per year. And the hotspots of phosphorus glyphosate in the USA is Corn Belt, the Central Valley of California, and the Texas Plains. If you consider the map C, we can see for the Ohio state, the glyphosate application in the fields is really higher in the western part of the state, and that is in between 19.56 to 227.08 kg phosphorus per kilometer square of agricultural land. So how this kind of herbicides transport from soil to water. So there are different kind of factors that can have the influence of this kind of transportation, and those might be timing of the application of herbicide, the doses of the application, frequency of the herbicide application, climate, hydrology, if you consider more specifically the flow routes, and the soil composition and structure, according to Kendall et al. 2010. And this figure, we see that different kind of transport system from soil to the water. So there are different kind of impact of herbicide on human and the immunity of human. For example, if we start from here, like digestive effect, then cellular effects, carcinogenic effect, this is very dangerous and serious issue. Reproductive effect, then cardiovascular effects, and cerebral effects. The EPA's proposed herbicide strategy. So as we are using different kind of herbicides for our agricultural production, the EPA came up with some strategies, and the Endangered Species Act was passed by Congress in 1974. However, in recent years, the EPA has been under fire for not meeting the obligations outlined within the Endangered Species Act. So it's not good, I think. Reducing the herbicide use strategy. We have to use herbicide, I know, but we have to follow the minimum limit. However, there are some other solutions. If you consider different tillage, mowing, mulching, flaming, and the use of cover crop for our agricultural production, it can also be helpful to reduce the use of herbicide. And another strategy might be the integrated weed management. The EPA's proposed herbicide strategy, so they made a draft herbicide strategy based on 3 steps framework. Those are identifies potential impacts to listed or endangered species, and the second step would be determine mitigation measures for protection of the listed or endangered species, and the last step would be analyze the extent of those restrictions according to locations, crop type, and the potential of herbicide exposure. So these are the references. You may check it out to know more about the figures and all of these. Thank you so much for your attention. I think you have questions.